Hello, everyone. Welcome back. We continue to study chapter 2. Okay, today we study the last part of this chapter. Part 3, highway environment. There are various environmental conditions which influence subgrade and pavement engineering. This part first introduces typical impacts of the environment, then discuss on 3 environment-related Chinese specifications: temperature and water are the 2 basic environment variables. Water may include surface water from rainfall, mild snowing, standing water, and undersurface water from water table or capillary action. Temperature may be high temperature, low temperature, and temperature gradient. Environments influence subgrade and pavement surface ability, as shown in this figure. Temperature and water may influence material stiffness and strength. Changing temperature or water may result in additional stresses, which influence subgrade and pavement stability and durability. Sometimes, excessive water may result in safety-related issues. For example, skidding resistance. Follows are a few examples, as shown in these 2 figures. High temperature results in decreasing of the asphalt mixture's dynamic modulus, while increasing water contents may result in decrease of the soil resilience modulus, as shown in these 2 figures. Water and temperature may induce pavements additional stresses. The additional stresses coupling with the traffic-induced stress result in various pavement stresses, such as thermal cracking and bloating up. Since temperature and water are varied from time to time during a year, the soil stiffness values are varied from time to time, as shown in this figure. During the winter time, the soil subgrade has higher stiffness, while its stiffness decreases during spring and summer. As a result, pavements have cracking during winter and rotting during spring and summer. Obviously, environmental conditions are closely related to subgrade and pavement performance. In order to quantify the environmental effects, standard of climatic zoning for highway was developed and took effect on January 1st in 1987. According to the standard, the entire channel is divided into 7 level 1 natural zones, which are denoted by 1, 2, 3. The level 1 zones are further divided into 33 level 2 zones and 19 deputy zones. The level 2 zones are denoted by 1, 1, 1, 2, 2, 1, 2, 2, while the deputy zones are denoted by 2, 2A, 2, 2B. And the level 2 zones, level 3 zones may be subdivided by each province. Details about the climatic zoning can be found in the standard. The 7 level 1 zones can be categorized into the low temperature zones, or LT zones, high temperature zones, or HT zones, and the minimum temperature zones. or empty zones. LT zones are 1, 2, 6, and 7. HD zones are 4, and empty zones are 3 and 5. The same climatic zones, subgrade and pavement have similar environmental conditions. It is recommended to look up climate zoning for highway at the very beginning of your highway projects. High temperature and low temperature water are the three key environmental factors in asphalt pavement construction. In outdoor facilities asphalt pavement construction, climatic zones for asphalt pavement was developed and included in asphalt pavement construction specification in 2004. The climatic zones are divided based on high temperature, low temperature, and annual rainfall. According to the specification, high temperature has 3 levels. Low temperature has 4 levels, and annual rainfall has 4 levels. The climate zones is combination of high temperature, low temperature, and annual rainfall. For instance, the zone 132 has the following features. High temperature is larger than 30 Celsius, and low temperature is between the -9 and 21.5 Celsius, and the annual rainfall is between the 500 to 1,000 millimeters. For concrete pavement design, temperature differences, delta-T, may result concrete slab cracking or blow up. The concept of maximum temperature gradient, TG, is used for calculating delta-T. As shown in this example, the maximum temperature gradient is TG, and the concrete thickness is 240 millimeters. The question is, calculate the temperature differences between the top and the bottom of concrete slab. The solution is delta-T equals 0.24 times TG. The TG in the equation is critical to concrete pavement design. In the National Asphalt Pavement Design Specification, the maximum temperature gradient is recommended. One can find the TG according to the level 1 climate zoning. For instance, the project is located in the zoning 3. The TG is between 90 and 50. If the 90 is selected, TG equals 0.24 times 90 equals 21.6 Celsius. More details will be introduced in Chapter 6 of this online course. Okay, that's all for today's lecture. Appreciate your listening, and see you next time.